Alright guys, today we're going to look at electrolytic stoichiometry. So we're going to tie in some stoichiometric calculations along with these electrolytic cells. The basic idea here is that when we are dealing with electrolytic cells, what happens is the metal is going to plate out on one of these sides. Now the term plate out just means that the metal is going to form. On this side, because again, this is that zinc copper reaction we've been looking at throughout this whole section here, the copper metal is going to break off into ions. So what's going to happen is the metal is going to convert into ions and electrons. So as the electrons move into the battery, because the battery is pushing electrons in this direction and drawing them through this wire, what will happen is the copper is going to form ions. So as a result, the solid is going to look like it's going into solution, right? So the metal is going to get eaten up and look like it's coming off. On this side, the metal is going to start to build up. As that zinc starts to go from zinc ions to zinc solid, it's going to plate out on the surface of the zinc. So it's actually going to get heavier. And what we can do is we can use some general principles of electric current to figure out exactly what that mass is. So in order to do that, we just need to know a few things. One, we need to know something about current and the amount of time that the current is applied. Okay, so if we know the current and the time interval, what you can do is you can figure out the mass of the amount of solid that's going to plate out, or the volume of gas that's produced, or the amount of liquid that's formed, depending on the particular reaction. The idea is that we just are going to use moles in these calculations. Now for current is going to be we're going to use a capital I for current. So this I here represents current. Q is the charge, okay, that's going through the wire, and T is the time. Now down here we're going to look at the unit for current, and the unit that we use is A for amp. And since we're talking about charge, we're going to talk about coulombic charges, or Coulomb charge, and the Coulomb charge is going to be put on the top, and then time is usually done in seconds. So for amps, the unit is usually Coulomb per second. Okay, that's what we deal with the amps. Hopefully you know this from physics. If not, no big deal. We can kind of work through it here. It's pretty simple. All right, sorry, it's kind of small, but what we're looking here is we're going to determine the mass of zinc that's going to plate out when 10 amps is placed for 30 minutes. So we got our time interval, we've got our amps, through a solution that has zinc ions in it. All right, so the way we're going to do this is we're going to start with that time interval, the 30 minutes, because we know that we have 30 minutes that are going to pass. First thing we want to do is we want to look at what that amp is. I guess not the first thing. The first thing was to write that. But the second thing is to look at what amps are. Well, amps are Coulomb per second. Well, since this is in seconds, our first step here, again, I keep saying first step, it's not really a first step, but our next step is to go from 30 minutes to seconds. We're going to figure out how many seconds that is. Then what we can do is we can use the amp to figure out how many coulombs we have, right? How much charge has gone by. It's essentially what we're doing is how much charge has passed through the wire under this amount of time. So if we measure the ampage, we can do that. All right, so at this point we're going to use amps. Here's just a conversion between seconds and minutes. Now, we're going to go from the Coulomb charge to the mass of zinc. We need to use something that connects us back to the balanced equation, because if you remember the equation, what's happening is zinc is gaining electrons. Okay, so according to the balanced equation, the zinc solid that's forming is because the zinc ions are gaining 2 electrons. So that's 2 moles of electrons for every mole of zinc that's going to plate out and form a solid. So we have to somehow connect this back to the moles of the balanced equation, and that's why we talk about this as stoichiometric for electrolytic cells. Okay, for the stoichiometry. All right, so we're going to do that. We're going to use what's called Faraday's constant. Okay, Faraday's constant is the constant that connects the Coulomb charge to moles of electrons. For every 1 mole of electrons, the charge is 96,500 coulombs. So now what we can do is we can figure out how many moles of electrons we have to pass in that time interval if this is our ampage. Okay, let me write the F again. Okay, so that would be a cursive looking F thing for Faraday's constant. Now what we do is we say, okay, if we have moles of electrons, we then go to the moles of zinc, because we know from the balanced equation that if I have 2 moles of electrons, I have 1 mole of zinc that's going to transfer between the two. And I guess I should make this not electrons, but I should make that zinc 2 plus ions. And then finally, for every zinc 2 plus ion, I can then convert to the solid zinc that forms. All right, so then I would go to the moles of zinc, and I would say that that is equal to 65 0.38 grams of zinc. Maybe 2 plus ions, 2 plus, and I guess instead you could probably have just converted, or it doesn't really matter, but you ended up with the same thing. The difference in mass between the ion and the solid is not really a big deal. I probably should have made that a solid, but it's not going to change anything in the end. When I do this calculation, put that into my calculator, I find that I have 6.10 grams of zinc solid forming. Okay? And that would be it. So that's pretty much how you do this. Now, one other thing you might be able to do is instead of converting to the mass, you might convert to the volume of gas, or you might take those number of moles that you would find here, and you could convert that using PV equals nRT to find the volume. You might find the pressure. You might take the mass and say, I need to plate out this mass. What time interval should I have it undergo? Again, you would have to have the amps, and you would just do these backwards. So again, I'm not going to do all the variations on this, but that's the general calculation. Alright guys, that pretty much ends this unit, so I think we'll just be reviewing from this point on, and I'll see you guys later.